Okay, this is 5.5b, inversive matrices, bottom of page 483, college algebra. Now the last example, example 2, we verified that one matrix was the inverse of another by multiplying them together and getting our identity matrix. Now what we're going to do is I'm just going to give you one square matrix, and I'm going to see if there is an inverse to this square matrix. So what I'm going to do is I'm going to use Gauss-Jordan elimination method to find out if there is, or what the inverse is, if one does exist. So what we're going to do here is we're going to form an augmented matrix consisting of A on the left side and a 2 by 2 identity matrix on the right side. So what we're going to do is write this as -2, 3, -3, 4, and remember augmented means we put this line here, and we're going to have another matrix over here like that. Okay, so that I have here on the right is my 2 by 2 identity matrix. Okay, so what I'm doing here is I'm trying to find another matrix that when I multiply it by this, I'm going to get this. So the way you do that is you use the Gaussian elimination, or in this case the Gauss-Jordan elimination, and we're going to try to change this to a 1, this to a 1, this to a 0, and this to a 0. This will also change, but when we're done, this here will move over here, and whatever numbers are here will be the inverse of this here. Okay, so we're just going to do Gauss-Jordan elimination to change, or to be able to switch this over here, and whatever's over here is my inverse. So let's see. First, we've got our augmented there, and everything looks good. Now what we're going to do is we're going to take and try to make my first, this -2 here, we're going to try to make that into a 1, because once that's a 1, we can change this to a 0. Then we'll change this to a 1 and try to change that to a 0. Okay, so we're going to go through the whole Gauss-Jordan method there. So I'm going to multiply this first row by 1/2, and then that'll give me a 1. That'll give me a -3/2, and that'll give me a -1/2 here, and a 0 there. And my bottom does not change at all. -3, 4, 0, 1. Okay. And now I'm going to take row 1 and multiply it by 3, so that I can make this into a 0, and you're going to go through the whole Gauss-Jordan elimination there, and you're going to find out that your A to the -1, when you're all done, is going to look like this. It's going to be 1, 0, 0, 1, and we'll just write it augmented here and show you how it was switched around. Okay, so it all switched around to look like that. So, whoops, that's not the identity, or the inverse. The inverse is then equal to the 4, the 3, the -3, the -2. Okay, so that is the inverse. And we showed in example 2 that that works. So here's what we started with. Here is the inverse. Now notice the numbers are the same. They're just moved to different places here. So anyway, that's how you would find out what the inverse is if there is an inverse. So let's look at a bigger one here, which would be example number 4, top of page 485. So what I'm doing here is I'm trying to find the inverse. I'm trying to find A inverse right there, given this matrix right there. So we're going to do it the same way. We're going to write it as an augmented. So we've got a 3 by 3. Augmented 1, 0, 0, 0, 1, 0, 0, 0, 1. So again, we're going to do Gauss-Jordan elimination to get all of this moved over here, and then this here will be over here, and we don't know what numbers that will be over here. So you'll do your whole Gauss-Jordan elimination, and when you're done, you will get 1, 1, 0, 0, 0, 1, 0, 0, 0, 1, and I'm not going to do the whole elimination. You did that in the last lesson until you're probably sickened by it. So let's just assume that you know what you're doing, and this ends up being the inverse. 6 over 5. So you end up with quite a messy inverse here. 3/5 and -2/5. So that ends up being the inverse of that up there. So if a matrix has an inverse, we say it is invertible. Is invertible means I can take an inverse of it, or they also call it non-singular. Okay? When we can't take the identity matrix using the Gauss-Jordan method, then no inverse exists. And that happens when we get a row that's consisting entirely of zeros. When we do all of the Gauss-Jordan elimination and we get, if you've noticed that every row that we do, whether it be the first row or the second row or the third row, we always have a 1 in a row. Well, if we're doing Gauss-Jordan elimination and we don't get any 1s, it's just zeros, then there's no inverse. Okay? If that happens, then we say that the matrix A is not non-singular. We say that it is singular. So if there is no inverse, it's singular. If there is an inverse, it's called non-singular. Okay, so the next video we're going to show is solving systems of equations using inverses. So we'll start that in just a minute, 5.5c.